Let's completely dismantle the outdated ways we study, right here, right now. Today, we're unlocking the biological cheat codes to your brain's operating manual. Look, if you've ever felt like your memory is just kind of holding you back, I've got some genuinely fantastic news for you. It's not a lack of intelligence, not at all. It's really just a lack of strategy. So in this explainer, we're going to fundamentally change how you absorb information, making it so fast and so effective it honestly feels almost unfair. Let's get into it.
Okay, let's start by validating a universal pain point. You know the feeling, right? You sit down, you read the exact same sentence 5 times. It feels super familiar, but 2 hours later, just a total blank. Your brain deleted everything like it never even happened. Well, here's the secret nobody tells you. Your brain isn't actually failing you here. It's literally designed to delete passive information. Think about it from a survival standpoint. Remembering every single tiny detail of your day would completely destroy your focus. Your brain is constantly asking, hey, is this important enough to keep? And if not, it dumps it.
So we desperately need a paradigm shift. We have to stop treating our brains like computer hard drives. The storage device myth is how most of us study, right? We read, repeat, read again, and try to hit save on the file. But memory is not a hard drive. The reality is that memory is built through reconstruction. Your brain strengthens information when it actively retrieves it, not when it just passively sits there and receives it. Which brings us to our first scientifically backed hack, active recall. Essentially, this is the process of strengthening memory pathways by actually forcing your brain to retrieve information. It's that tiny, kind of frustrating struggle of pulling a fact out of your head. That exact struggle is what builds the memory. The harder that retrieval feels in the moment, the stronger the memory becomes right afterward. It's literally like lifting weights, but for your neural pathways.
And honestly, this is the exact difference between average students and top performers. The passive trap is so easy to fall into. You read a page, you get that false sense of familiarity, and you move on. But passive input just doesn't convince your brain that the information matters for survival. The active approach, though, that changes the whole game. You read the page, you close your notes, and you force your brain to remember. Testing yourself will absolutely always beat rereading, every single time.
Now, you might be wondering, what if I try active recall and totally fail? Like, what if you close your book and only remember a measly 20%? Actually, scratch that. That is perfect. Seriously, even if you only pull back 20%, that difficulty is a huge green flag. It's a sign your brain is adapting, not failing. That initial struggle tells your brain, oh, wow, we needed this info and couldn't find it. We better reinforce this pathway right now. So embrace the 20%.
Let's think about how your brain handles raw data for a second. Have you ever noticed how you can easily belt out song lyrics from a decade ago, but you completely forget a definition you just read yesterday? It's crazy. The brain drops isolated facts incredibly quickly, but it absolutely loves incomplete patterns and meaningful relationships. This means if we want sterile, raw information to actually stick around, we have to turn it into connected relationships.
For example, instead of forcing raw repetition by chanting, ATP is the energy currency of the cell over and over until you're blue in the face, create a relationship. You just say, ATP equals a battery pack for cellular work. Boom! Attaching a relatable, everyday analogy gives your brain a meaning hook. Meaning creates memory hooks, and the more hooks you have, the faster your recall becomes. So stop asking how to repeat things and start asking how to connect them.
But even with those awesome meaning hooks, we still have to face the ultimate villain of our story, the 24-hour memory drop. Researchers have found that without a review, memory drops aggressively within the very first 24 hours. If you study something today and never revisit it, your brain immediately labels that unreviewed data as temporary, and poof, it's gone. This is exactly why you can study for 8 hours straight and still feel like you forgot everything on exam day.
To combat that massive memory drop, we use spaced repetition. This is huge. It simply means reviewing information right before your brain is about to forget it. Not too early, and definitely not too late. It creates incredibly long-term retention with significantly less effort than cramming. Seriously, this is arguably one of the most powerful memory systems ever discovered by cognitive science.
Here's exactly how this builds into a practical, real-world schedule. Day 1, you learn it. Day 2, a quick review. Then you start spacing it out. Day 4, Day 7, Day 14. Spacing out your reviews exactly like this completely prevents the absolute panic of cramming. And the best part? With each step on this schedule, the review actually takes less time, but the memory becomes deeply, deeply entrenched. It proves your brain remembers repetition over time, not repetition in a 3 a.m. panic the night before.
Let's switch gears for a second.
Have you ever wondered why you can remember an incredibly embarrassing moment from middle school in vivid, horrifying detail, but you can't remember what you had for breakfast on Tuesday? It's because emotion is a literal memory superpower. Emotion signals to your brain that the information has high stakes, that it truly, truly matters. A bored, distracted, half-awake brain rarely memorizes deeply simply because there's no emotional weight to the data.
The cool thing is you can actually manufacture this emotional intensity while you're studying. Try teaching the concept dramatically to an imaginary audience, or use urgency timers to create a fun little race against the clock. Attach genuine curiosity to the topic by turning it into a challenge, or just vividly visualize your future success while you're learning. Emotion increases attention increases encoding, and encoding creates rock-solid memory. You've got to make your brain care. Okay, let's put this into practice with a biological cheat code called the Blurting Method. Honestly, this technique feels almost illegal because of how well it works. Step 1. Study normally for 20 to 30 minutes. Step 2. Close everything. Step 3. Take a totally blank sheet of paper and just blurt out. Literally write down absolutely everything you can remember. It can be incredibly messy, that's fine. Step 4. Open your notes back up and compare to see exactly what you missed. It forces active recall, retrieval practice, and error correction all in one intense burst.
Now, we also need to talk about where you are. Your physical environment plays a massive role. In context-dependent learning, your brain actually subtly attaches the memories you're forming to the physical context and environment around you. This has huge implications, because if you constantly study while scrolling on your phone, or listening to chaotic background noise, or sitting right in front of the TV, your brain is literally learning distraction as part of the material.
Here's the golden rule. Shallow attention creates shallow memory, period. If you want to enter deep encoding mode, you must aggressively protect the first 25 minutes of your study session. I mean it. Block all notifications, put the phone in a completely different room, no multitasking, no quick text checks. Memory formation requires uninterrupted attention to boot up properly. Fragmented attention will ruin even the highest level of natural intelligence. And this next part, this is the part people underestimate the most, and it honestly breaks my heart. Sleep is a neurological requirement for memorization. Sleeping after studying isn't laziness, guys. It is the absolute vital period when your brain actively replays what you've learned and physically transfers that information into long-term storage, especially during deep sleep. Pulling an all-nighter sacrifices the exact biological process required to stabilize your memory. Sleep is studying. To truly master all of this, we have an advanced strategy called interleaving. This is a brilliant concept that combats that false illusion of productivity. You know, the one that comes from studying just one subject for 4 straight hours. Interleaving means strengthening your learning by intentionally switching between different topics. It forces the brain to repeatedly wake up, re-engage, and figure out which strategy to use for this brand new set of information.
So, instead of a massive monolithic block of one subject, divide your study session up. Do 45 minutes of math, jump over to 45 minutes of biology, and then hit 45 minutes of chemistry. Now, I'll be honest, controlled switching like this feels way slower and a lot more frustrating initially, but that extra mental friction, it drastically improves your actual performance during exams. It trains your brain to retrieve answers under changing, unpredictable conditions. So, the crucial point we're really arriving at today is that we need an entirely new way to measure success. We have to stop measuring our learning by the hours we sat staring at a desk or the number of pages we painted with a yellow highlighter. Those are just passive illusions of competence. Instead, we need to use active reconstruction metrics. Ask yourself, what can I actually recall with the book totally closed? What can I explain clearly to someone else? And critically, what actually survives after 3 days?
Let's wrap up with this incredibly powerful thought. Real memory is not recognition, it is reconstruction. Once you align your daily study habits with how the human brain actually operates biologically, memorization completely stops being a painful struggle. It stops being a chore and starts feeling like an incredible, almost unfair advantage over everyone else who's still just rereading their notes 5 times over. So, armed with all these new biological cheat codes, what are you going to reconstruct today? Re-engage, and figure out which strategy to use for this brand new set of information.
So, instead of a massive monolithic block of one subject, divide your study session up. Do 45 minutes of math, jump over to 45 minutes of biology, and then hit 45 minutes of chemistry. Now, I'll be honest, controlled switching like this feels way slower and a lot more frustrating initially, but that extra mental friction, it drastically improves your actual performance during exams. It trains your brain to retrieve answers under changing, unpredictable conditions.
So, the crucial point we're really arriving at today is that we need an entirely new way to measure success. We have to stop measuring our learning by the hours we sat staring at a desk or the number of pages we painted with a yellow highlighter. Those are just passive illusions of competence. Instead, we need to use active reconstruction metrics. Ask yourself, what can I actually recall with the book totally closed? What can I explain clearly to someone else? And critically, what actually survives after 3 days?
Let's wrap up with this incredibly powerful thought. Real memory is not recognition, it is reconstruction. Once you align your daily study habits with how the human brain actually operates biologically, memorization completely stops being a painful struggle. It stops being a chore and starts feeling like an incredible, almost unfair advantage over everyone else who's still just rereading their notes 5 times over. So, armed with all these new biological cheat codes, what are you going to reconstruct today?